What is an ionic compound? Ooh, we did touch on this a little bit, but just to really elaborate again, an ionic compound can be simply broken down. Okay, I'm gonna put a little question mark there, as in what is it? So an ionic compound is a metal and non-metal, and it just needs one of each, at least one of each. Because as we saw actually with yeah, exactly, the sodium hydroxide, that's an ionic compound. What if we had sodium acetate? Okay, that's sodium acetate. This is still an ionic compound. Why? Because we remember how we did it. We still split it. Okay, and when you split it like that, right, what you've done now really is assigned a metal part and a non-metal part. Because if you go through CH3COO, right, okay, that is really just hydrogen is a non-metal, carbon is also a non-metal, and oxygen are non-metal. So everything here is non-metal. Okay, and then the metal side, all we have is sodium. Okay, so that is really how you distinguish an ionic compound. But now the question is, you know, what if you have like ruthenium? Actually, I don't know how that one bonds. Let's say you had Fe2O3, okay, iron oxide. Is this an ionic compound? Well, you have to look at the periodic table for that, and these are the kind of things you have to memorize. When you highlight over iron, right? In fact, if you highlight over this part, it actually says what it is. These are transition metals. So these still count actually as metals. And so now you still have your metal and your non-metal, making this an ionic compound. Okay? And there are a few more trickier metals you have to get used to, like aluminum, for example. That is still considered a metal, even though it's all the way on the 13th column. Okay? You'll notice that there's a lot more metals typically than non-metals on the periodic table, but it's just very important that you know which the non-metals are to be able to say whether it's an ionic compound or not. And I would say the best thing to do is just get familiar with the periodic table and know what's a cutoff for each type of non-metal, so that way you don't accidentally assign like something to the wrong place, you know. So these here are the non-metals you're typically looking for. Okay, and these ones, so alkaline metals, alkaline earth metals, transition metals, post-transition metals, these are the kind of metals you're looking for as well to be able to say it's an ionic compound. Okay, yep. And they just talk more in this question about how they work. So an ionic compound, typically the way it's officially drawn is that when it's an ionic compound, let's actually use the iron, let's actually use something simple like sodium. When you draw the Lewis dot diagram, right, okay, it'd actually be like this. You would think that, let me actually draw it first like that. You think that they would share, right, like that, where they have like kind of a bond there. But because metals, they can just in a sense shed away their electron, they can fully in a sense donate the electron over to the non-metal, it'd actually be kind of more like this. So we have our negative, okay, and our positive. So if I have to actually space it out, it'd be like that, NaCl minus, whoops, that's supposed to be inside, sorry about that, it's supposed to be on the outside, so you don't confuse it with the, so you see Cl minus right there and Na plus. Okay, this would actually be the Lewis diagram. You notice that the sodium and the chloride are kind of completely separated because it's just giving this electron, they're not really sharing it like you'd see in like water, or even better like CH4. these ones all share it in a covalent bond, it's not going to be drawn like that. You'd still have C H H H H like that, and the whole thing would be together. Okay, but this is how you would do the Lewis diagram for ionic compounds, because they've given that electron completely to their nonmetal part. Okay. So let's move on to question 8.